Hello, participants. Good morning.
Amit Misra sir, shall we start?
Yes, yes, we can start.
Okay, good morning to everyone. I'm happy to welcome all the participants on third day of AICT sponsored 2-week faculty development program on cutting edge trends in deep learning approaches. I am also delighted to welcome Mr. Amit Mishra, International Corporate Trainer and Data Science Consultant, AI Council, New Delhi. Today he is there with us to share his experience in the key concept in machine learning. Hope all the participants will get in-depth knowledge in machine learning and also enjoy this session. Now I request Amit Mishra to take over this session.
Hello, everyone. Hello, all the participants. I welcome you all in this training program on machine learning today. Today we will be seeing uh, seeing the details about what is machine learning, and we'll also have a basic introduction about what is the flow of machine learning, what are the things that we need to know. So let's get started. So I believe that till now like you will be having an idea about what exactly is machine learning, and what is Python. All these things are the prerequisite now. So we'll see, and I will have a look on to the different type of machine learning, and what are the prerequisites. Um, so those things we need to take, and then we'll take some example for a complete machine learning task as well. All right, so let us proceed. So as far as your different type of machine learnings are concerned, we will be understanding that our machine learning has two paths. Majorly, there are three different type of machine learning, but out of that, the two are mostly used. So we'll have a look on those two part. So those are your supervised and unsupervised. Majorly, these are the two categories. Supervised, if target level is available. So we will say that if label equals to yes, it will be categorized as supervised, and if label is not present, then it is called as unsupervised learning. In the supervised learning, we are having different varieties. There are two different type of problem statements. Further, when we say label, we generally say that it is all about the target, like the y part, and we are trying to solve it for the y. So try to remember that part. Now here if I'll see that if this label is continuous, then this comes under regression. And if label equals to discrete, then this comes under classification. All right, so we are having a details about in which circumstances our problem statement will come under regression, and in which circumstances our problem statement of machine learning will come under classification. There are different algorithms which are available to us that provides detail about which algorithm to be implemented if your problem statement belongs to classification or if your problem statement belongs to regression. For the regression, we'll be using some of the algorithm names. They are called as linear regression, logistic regression, decision trees, random forest, etc. There are many other algorithms which are available. In the classification, we are having k nearest neighbors, just a minute. This is not correct. Yeah. In spite of that, we can use a support vector machine, regressor into this part, into regression part. Okay, here k nearest neighbors and logistic regression. Then decision tree and random forest is something which is common. Decision tree and random forest is common. And support vector machine is also common here. In short, it is called as SVM. These are just name of the algorithms. But in this part, you will be using classifier. Decision tree and random forest can act like both. It can be like a regressor, or it can be like a classifier. In the unsupervised learning, as I have described it on the last day, on the first day rather, when I was taking the session on the first day, first half of the session, I discussed about the unsupervised learning, and I clearly said that this unsupervised learning role is to find out the similarity and group them on the basis of that similarity. Group what? Group the data, or they group the samples with same characteristics. So in this part, we will be trying to group them and form the cluster. Group the samples with same characteristics. Group the samples with same characteristics. Okay. Example of the algorithms: hierarchical clustering, K means clustering. These are the two common algorithms which are available to us. And I guess this much information is good enough to recall what exactly your algorithm have. Okay. Um Now, ma'am, can you just help me out in? Hello, ma'am. Ma'am, are you there?
Yes, sir.
Ma'am, can you tell me, like in the like in this session, the participants have already learned about like linear regression or something like that, because I can see linear algebra and all was discussed yesterday, and
Yes,
pandas and all.
yes, sir.
So can you tell me what are the things, like a basic overview, like what are the things has been discussed, so that I can get to understand what the participants already
Sir,
learned.
will you once again revise this, sir? No problem, sir.
Okay, okay. Let's talk about the flow of machine learning now. Flow of machine learning means what are the uh, what exactly when it comes to writing the machine learning program, what exactly we need to understand before we proceed. So in this machine learning part, as you have seen, we have discussed about the supervised and unsupervised learning, the types and their algorithms. Now we will talk about the flow of machine learning. Flow of machine learning, in this there are a lot of parts which we need to understand, that when it comes to writing a program in machine learning or data science, the flow remains same. Maybe in deep learning, slight changes will be there because of the problem statements, but most often it will remain as it is. So flow of machine learning starts with first, uh, you will be having a data set, like a raw data set it will be. From this data set, we will be feeding the data. Okay, now you need to understand here about how to read the file. read different data sets. Okay, like CSV file is there, or JSON file is there. These two will be must be read. Once you have finished reading the data, you will be applying the data manipulation. When it comes to data manipulation, we talk about here in the data manipulation. Data manipulation. In this one, we talk about handling missing values. If some part of the data set is missing, how to handle them. Okay, and then we perform some EDA, exploratory data analysis. We also handle here outliers, etc. So many things that we discuss in the data manipulation. This part is basically deal in data preparation, like removing all the noises, and so on. So this part is very very important, and this is the, you can say, this is where your exactly your data set will be prepared from the raw data set. Suppose your data set was in the HTML format and you want to convert them into a much better readable format by extracting out the important information from it. So you need the help of data preparation. Once your data is prepared, you will be performing here data pre-processing. Sometimes pre-processing is done, pre-processing. Data pre-processing is basically is about data normalization and data scaling. Sometimes replacing categorical data set or categorical values with numerical labeling. So pre-processing is very very important. In this one, we basically deal in with data normalization, data scaling, and we can replace our string-based categorical values with some numerical labeling, as uh, there is no space, like we can't analyze any string type of data. Categorical values, I hope you understand. And remember, then when we talked about the type of categorical data set, which was nominal, which was you can say dichotomous, and which were about ordinal. So these three were the categorical data sets. Now, once my pre-processing is going on, where we have normalized our numerical data, we have scaled down my data set, and we have replaced the categorical values with numerical labeling, our things are prepared. Once your data pre-processing is once your data is pre-processed, you will be extracting out the features. In this level, you will be extracting important features. I hope you remember that example of when I was dealing in with target marks, and I gave you some dummy examples of, say, serial number, then name of the student, age of the student, location of the student, hours of sleep, and hours studied. Sometimes sleep part can be like your hours rest. And this will result into a target that will be given by y. So all these things that you see here, serial number, name, age, location, hours sleep, and hours studied, in this one there will be some sort of a features. Age is a feature, hours sleep is a feature, and hours studied is a feature. These are the three main features. Then how we picked it? We picked it logically. Suppose we are having a lot of columns. Let's say we are having 70 such columns. Not everywhere this logic will work. We need some concrete results, and that will be given by correlation. One of the way to choose the important feature with respect to the target. Always remember that your features will be selected on the basis of the target. Okay, the better is the relationship with the target, that will be considered as features. If there is a weak relationship with the feature, that means your those are not your correct features. So the relationship between the x value and the target y must be stronger. So features will be chosen by choose features by correlation. RFE, etc. Once your features have been selected, that means you have got your perfect y, x, and with respect to your y. This will result into now almost after this. Sometimes after features also we do some pre-processing as well. Okay, but it is subject to change. Like sometimes we transform the data for getting the better results or better predictions. Now here what we will be doing is we will be splitting up these features into train, we are getting the data in terms of train and test. Once we have got our train and test samples, this is like your train data set and this is like your test data set. We have got our data set ready with train and test. Okay. So when we say train data set, it is very, very important. As you know that machine learning is a two-step process, especially with the algorithm. So next first part is your training. Always first you need to train your model. So we will be doing the training part here. In the training part, you will be feeding the X part, which is also called as your features. The chosen feature by this properties, correlation or RFE. And then you will be using your Y, which will be target. Generally, this split ratio will be of 80% to 20%. This is the split ratio we use preferably. So X features and Y target, we have fed both of them into my train algorithm. Sorry, into the algorithm. And your algorithm will basically map your X and Y. Okay, but I'm talking about that we should have X and Y both. So that means I'm talking about supervised learning, of course. In unsupervised learning, there will be only X, there will be no Y. Always remember that part. So both of them has been feeded and this algorithm will now get converted into a trained algorithm. Testing or test algorithm. X features test. In this part, we will be taking just the features and the same algorithm for which we have trained it. The same algorithm will be used. The trained algorithm, and this is gonna give us the y hat. This is called as predicted output given by y hat. Okay, so that's how the things work with the training and testing. We will be having our x features ready and your y target ready, and we'll be feeding them into the algorithm. Say linear regression we have used, and we have first trained it with the samples of x and y, and then we will be testing them. In the same algorithm, for testing phase, what you will do is you will be feeding up the new features, all right, and then those will be your predicted result. After this, you will be analyzing your result. So analyzing part, or you can say matrix. So this is about your analyzing of machine learning. So we will be taking up here the x new sample. This is your exactly the new uh, independent of this train and test. Neither it is part of train data, neither it will be part of test data. Okay, or let's say the results of this y hat you will be using, and you will be calculating the error. Error will be calculated by difference between actual value and the predicted value. Difference between actual and predicted y. This is called as your error. The reason behind why we should analyze our results is maybe sometimes the model looks good. We need to still be pretty sure about whether the flow that we have followed is actually giving us the correct results or correct outputs or not. So with this, we will be getting the surety about that our results are 100% correct. All right. So any questions anybody would like to ask here? Like in this part, if anybody would like to ask some question, please ask on the chat window. What are metric available, sir? JSON file. JSON file is a file name. JSON file is a file syntaxes. Uh, they are basically in the key and value pair. JSON files are key and value pair. Just like the dictionary syntaxes are there. Uh, the example of JSON file will be when you extract out the Twitter data. Those are majorly in the JSON format. So it is like you can say there are three categories of the data sets, right? Structured, unstructured, and semi-structured. So these two fall under the category of semi-structured data. JSON file looks like this: key and value. Suppose name, user name. So value will be, let's say, X, Y, Z, 1, 2, 3. Okay. Similarly, in this there could be one of the few more details. Let's say email. So this is the example. These are just the example that now the example is coming up. Okay, so that is your JSON file. What are metrics available? Metrics available will depend upon what kind of an algorithm you are using. Uh, let's say if you are using a regression algorithm, then your metric will be R squared or a mean squared error, MSE. I'm just giving you the names. So it depends upon regression and classification. Metrics are measure of accuracy, of how accurate your model is. Or in other terms, you say model performances. Algorithm, model, algorithm or model performances. So this part is all about, say, for regression, we are having R squared, adjusted R squared, mean squared error. Just remember these names, okay? We definitely, I guess, in the upcoming sessions, we will be like me or somebody else will definitely talk about them in detail. So in regression, these three are more than enough: R squared, adjusted R squared, and mean squared error. The next part for the classification are ROC curve. Okay, then classification, report, which includes precision, recall, specificity, F1 score, etc. These are the details that we follow to be sure about whether my results are coming good or not. Okay. Uh, Classification part and regression part are the two different type of problem statements of supervised learning only. Next part is which approach is suitable for healthcare, supervised or unsupervised. It depends upon the problem statements. If your problem statement demands is already labeled, then it will be categorized as a supervised learning. Let's say, for example, if you are having some medical images available to you, like of tumor, any tumor is there, or cancer data is there, like benign and malignant type of image data are available to you. Just a minute, class. I'm coming in a minute. So, as you can see here, that it depends upon the problem statement. Security purpose, which is suitable for healthcare. What is the security purpose here? Either you will be having the problem statement of security layer, or you will be having the healthcare. So, how both are like linked together? If you can elaborate your question, then only I can answer this. Kindly elaborate your problem. All right, so I will be proceeding ahead. I believe that we are done with the problem statements. Okay. So, did you all have started working on collab? Like I can see the collab. Machine learning does not work on that level. Machine learning works on analysis of the data. If you want to send a record from one place to another place, that's your common problem statements. Just like any other security layer, if you want to add, you can add it. Machine learning does not talk about those type of things. Especially this transmission part is not something which is relevant to ML at all. Machine learning is only about analysis. It's not about your transmission of the data or the security layers of the data. A transmission layer, TCP protocol, etc. So for that, whatever your traditional thing is there, it will be followed. Now go for Google Colab, all of you. So I was asking something like, did you work on Google Colab? Did you all started working on Google Colab? Right? Yes and no. Like for the Python, I can see like you might have worked on Google Colab, right? Pandas part is done. Pandas, NumPy, you all are aware about it. What are pandas? PANDAS package, pandas package, NumPy package. These are already done. Just write yes on the chat window. Pandas package is done. Okay. So I will be just describing you the important details about the pandas and some data visualization. So just click on new notebook, all of you. Start with Google Colab and start with a new notebook. Start with new notebook. Somebody's mic is on, I guess. Again, somebody's mic is on. Kindly mute yourself.
Sivakumar sir.
Okay. Thank you, ma'am. So I was saying like just you can click on new notebook and start with the Google Colab. So when you will be starting off a Google Colab, it will look like this. Please connect it first to the cloud server which is running. All right. So this is how it looks like. Now you will go to the untitled 0. So here you can just name the file as data analysis. Okay, I'm not gonna discuss the pandas in depth here, as pandas part has already been taken. So here I will be just discussing about some of the important point that I believe that was not like I guess it might have not been discussed yet. How about data visualization like matplotlib, all these things you have worked, like matplotlib package has been discussed. Just can you just respond in the chat window? Matplotlib is it discussed already? Your data visualization part is discussed or not? Can anybody please try like respond little bit discussed? Okay, fine. So we will be discussing here about data analysis. In the data analysis, we'll first import pandas as PD. This is a like you can say the way we do it is with the help of this part. And class, for your references, if you are not a good coder or not great in typing, I will be saving up all my work, all this data analysis work. Definitely by the end of the day, I will share this file as well. But if you want to do it parallelly, I'm just preparing the. This is just a sharing platform, okay? So this is not a file. This is not something else. This is just something that will be sharing with you all so that you can write your code, okay? Suppose you have missed out any line or something, you can make it correct. So I request you to open both the links and let's get started. All right, class. So here, as you have imported the packages, sometimes we require the import numpy as np as well. So both the things will be required. Import both the packages. Let's start. So from here, you can copy the things. Okay, if you are not good in typing, preferences you can type, and to execute the program, you have to press Shift and Enter. I hope you remember it. So you need to press Shift and Enter, then only it will be executed. Anything else you need to understand before I start writing the code about collab, which was not earlier, like you were not clear about earlier and you want to have a detail about it? So to execute the line, like in this one cell, you can write many a code, and to execute them, you will be using Shift and Enter. Shift and Enter, Alt and Enter, Control and Enter, any one of these you can use. Shift and Enter will basically generate a new cell as well. So it is much better for you to move on. Otherwise, you have to add the cell by the code. Okay. So shall we proceed? I guess you all have opened the file.
Yes, sir.
Okay. Now we will be I will be sharing you my GitHub link for the data set, from where, like, see, this is a cloud platform, so we require the data set. So there are so many data sets which are available. We'll be choosing one of them, which in which we'll be working. The first data set that I'll be taking here will be insurance.csv data. Please take the link of this data set from the chat window. To read the data set, we require the help of pandas. So pd dot. This data set is a CSV format data. CSV stands for comma separated values. So we'll be using about read underscore. You can see a lot of functions are available. To read the JSON file, you are having read underscore JSON. To read HTML file, you are having read underscore HTML. For the CSV, we'll be using the CSV dataset. I'm given the link. And your pandas packages will read this data set and will convert itself into a data frame. This is called as data frame. Just for your references, I know you already know what is a data frame. I'm just giving you a quick revision. Data frame is something where your values which are there from any format, like from any semi-structured data. Like here, this is your structure of the data where each and every attributes are separated by comma. In this section, we are just reading and converting my data set into a data frame. Data frame is an Excel-like environment. So you can say like from a CSV format, you have converted your data into a row and column format or 2D format. Start with a link. To display anything, you can use display function. Don't use print to display, okay? Because print will convert itself into a completely honest, like completely different manner. It will represent, though your data set is still data frame, but the representation will be entirely different. You see, now, this is something which is weird. This is comfortable to us. It looks like an Excel environment, so better to use display, not to use print while displaying your data. Okay. By the way, the editor which we are using, this is your interactive Python notebook. It is creating an interactive Python notebook file, which is, you can say, a reference of Jupyter notebooks. Let's proceed ahead. So till now, what we have done is we have just read a data set. It's already been shared. Please check the link of the data set. Let me share you the link once again. Yeah, it has been shared again. The codes are available in the snipper class. So you are requested to kindly use and take the help of snipper link, which will be much more beneficial for all of you. If you are low, like most of the, like you all are mostly faculties or students. Students, they can like type the code faster, but I believe like it won't be the same on the faculty side. So for you people, for all the faculties, I'm preparing this snipper link. This is just a code sharing platform. Okay, it is not a file, nothing. It is just a code sharing platform. Whatever you are doing, kindly just copy the things and don't cut it. So use Control C and Control V. In the data manipulation part, we basically focus on if any missing values are present in our data set. Okay, let's check the information about it, the detailed information. Insurance underscore df.info. This will give us the info, which will be an information. So age is there with data type integer 64. Sex is there with data type object. Body mass index is there with float 64. Children is there integer 64. Smoker is there with object type. Charges is there float type. Object basically denotes here string data type. String data type is represented as object, and float is obviously float. 64 means 64 bit. That is the maximum size. 2 to the power 64 is the maximum size of the data. Like the range of the data will be 2 to the power 64. How many total entries are there? 1338, which starts from 0 index to 1338 indexes. I hope you remember I hope you understand the indexes. As you can observe here, 0 index, 1 index, 2 index, and this is your index for the last row, which will be 1338. In Python, your index values or position indexes are always will always start from the whole number. Whole number in the sense means it will start from 0. All right, so start with all this thing, and as you can observe, information is clear to all of you. Any questions in this? Then we will be seeing here a very important part, and that is about checking is null. Is null gives us representation of true and false. True means the missing values are present, and false means missing values are not present. Okay, I'll just put up a comment here. True, missing values are found. False, missing values not found. So if it is true or false, this is one of the thing. Now I will just sum those values. See, on other side, you can understand like false means 0 and true means 1. So I'll just sum them. If there will be any missing values, they all will be represented as the number of count will be present. Okay. 0 indicates No missing values. If there will be any number here or any count will be there, that will be called as your missing values are found. So isnul.sum will basically indicate that your missing values are found, like there are no missing values. If there will be any one of these will be one or two or three or whatever the count comes up, that many missing values will be there available. I'll take an example after this where I will like discuss about how to handle the missing values. Okay, so as far as machine learning is concerned, your missing values, understanding about the missing values is very very important and essential. Otherwise like you will get an error, like your machine learning algorithm will not work because with presence of machine with presence of missing values you will always get an error. Okay, so handling the missing values in machine learning part is very very important. That's why I discussed about the shape of it. Sorry, I discussed in the flow chart. Right. So I'm just want to ask about like, did you discussed about lock and ilock, about slicing the data? Lock and ilock, is it bit discussed? Like pandas dot ilock or pandas dot lock or df dot lock or df dot ilock. Is it discussed? Okay. So great. Okay. After isNull.sum, we will be getting the idea about if any missing values are there. Okay. Dropping a column, dropping a row and dropping a column is important. So drop row and column. This is also one of the important part. Suppose if you have taken insurance underscore df, from this I want to drop some rows and some columns. I want to drop few of the rows and few of the columns. So I'll write here dot drop. So now the first default thing that we need to like we drop is rows. Okay, these are your row indexes. So you can pass the row indexes to drop that particular to drop your entire rows. So 2, 3, 4, 5, 6, 7. X is equals to 0. Drop default is dropping the row. So when we have like when we have used it, this 2, 3, 4, 5, 6, 7, those are your row numbers. So you can observe here clearly that those rows are not present anymore. This x is equals to 0 denotes dropping the row. Axis equals to 0 is all about dropping the row. Kindly perform this task. Next part is, after dropping the row, how to drop a column. So we need the column name in this case. As to drop the row, we use the row numbers. To drop the column, we require the column number or column names rather. So we'll write here insurance underscore df dot drop. Let's say I want to drop region. So I want to drop region out of it. I'll write here region. And if I'll try to execute it, it will say that it is not found in the axis. Why is it so? Did we missed out axis equals to 0? Still it will say that it is not found in axis. See, axis equals to 0 is default. I mentioned here, default is dropping the row, which is axis equals to 0. To drop a column, you require axis equals to 1. Then only a column will be dropped. No more region is present. Dropping a column with axis equals to 1. All right, completed. Any questions anybody wants to ask? Like, I hope these part are clear to you. Okay, so how to eliminate a row and how to eliminate a column, you should know about it. Very, very important step. Now, suppose you want to slice the data set, like slicing with lock and iLock. I guess you all know about it already. But there are many other like operations that you should know about it as well. Slicing and filter. There are group by as well, by the way, in this case. So you should know about those part as well. So suppose if you want to filter your data set, okay, for selecting particular column, how does we can do it? So let's say I want to select a column. So one part is you can write the column name, and you can pick the column which you want to select. If you want to select an individual column, only single value will be there. Single square, single list value is more than enough. And your X will be having all the details about age. But as soon as you want to move towards from age to BMI, like two values minimum you require, you will get an error. Because more than one value, see, one value is called as univariate and multiple values are called as multivariate. So I will name it as multivariate because there are two columns. So for multivariate representation, you will be using two square boxes. And there you go. These are your two details. Filter data like a query language, like a SQL query. I'll write here insurance underscore df dot filter like equals to, let's choose any one of the name, initial name, say A or S. So if those will be found like A, so it will see like where exactly small a is present. So wherever the small a will be found, it will filter out that particular column. So here you can see age has A and charges has A. Similarly, you can filter with the like complete name as well. Like suppose if you want not like this, but you want like this, then also it is fine. Not only just initial value, but you have to pass the column values. So here we are having A. So filter data like SQL query, which will be equal to like A. Filter your data set. I hope all of you are doing it smoothly, no problem at all. Any questions, any queries, if you want to ask, you can ask me. Everything is clear till now? So filter is like a query language where you will be writing like equals to the initial value or any value that will help you in filtering your data set. Just like lock and ilock uses the column name, the entire column name or index values. Here you use only just individual value or the entire column name. Both options are available. So is it completed? Till now, write yes on the chat window class quickly if it is done. Is it completed class? All right, let's proceed ahead then. So after filter, the another important part which I like really is unique display, unique values. This is also having some utility about understanding your data set. If your data set especially is categorical or sorry is discrete or continuous, to understand that you need the column name and check its unique value. So if I'll check the unique value here, you'll see like each and every data is very large in number. Looks like they are very uh, almost every data is unique from each other. Okay, let's do it for age. Age is like how many samples are there total? How to check how many samples are there? Dot shape. Dot shape returns us the number of rows and number of columns. Sorry, yeah, number of rows and number of columns. So how many samples are there? 1338 is your number of rows and 7 is your number of columns. So this returns or displays rows and columns. Number of rows and number of columns with dot shape. So 1338 is your number of rows and 7 is your number of column. Dot unique displays the unique elements which are present, or you can say it will eliminate all the duplicate values. Okay, it is easy to use dot unique and figure out whether your data is continuous or discrete. So say if I'll just want to check BMI, you see that body mass index is unique. Unique values are so large in number, and your age is just this many numbers. What I said, which one is out of these is continuous and which one out of these are discrete? What do you think? This age is discrete or continuous, and this body mass index is discrete or continuous? Write your reviews on the chat window. Write your answers on the chat window about it. Which one out of these, body mass index and age, is discrete or both of them are continuous? Is both of them are discrete or both of them are continuous? Kindly write your answers. Both of them are continuous. No, one of them are continuous and one of them is discrete. See, the definition of discrete was in the discrete part what I said. Discrete part will be limited in number, like a small in number. Their range will be small, but the continuous data will have a very large number or large range. Body mass index is continuous. Very important concept is going on. I'm going to use this in the in how to handle the missing values. So is continuous and this part is discrete. This part is discrete because of the reason behind that they are limited in the range is limited. Just a minute, class. So complete it and let's take a 5 minute break and then we'll continue. 5 minute break I'm taking and then we'll continue after this. Hello everyone. So let's resume the session back. Now in this part, as you can observe, that we talked about the how to choose which one is continuous and which one is discrete. Let's move ahead about sorting the values, like rearranging them. So let's say I want to rearrange on the basis of I want to rearrange the entire data set on the basis of body mass index, or I want to rearrange on the basis of age. Sorting the rows, data using column. Insurance underscore df, use age dot sort underscore values. This is about rearranging your data set into an age. Here dot sort underscore values by age. That is also a good move. Rearranging the entire values on the basis of the age. So minimum age is 18, maximum age is 64. After that, there are no insurances or no insurance that will be provided. So by age, now it depends upon if you want to have ascending order or descending order. So if you are writing ascending equals to false, it will be descending order, and default is ascending equals to true. Ascending equals to true. If you want to have, you want to choose a particular column, so in that by is not required. Just you require dot sort values and pick the column that you want to arrange. Let's say I want to arrange the charges. There are two ways of arranging them. One is on the basis of only individual value, or if you want to rearrange the entire overall sample on the basis of one particular column. So both are permittable here. You need to decide which part will be more beneficiary for you. So both are there, and you should know about both the examples. Ascending equals to true indicates that it is descending order, and ascending equals to, if I'm not writing anything, that means it will be ascending equals to false, which will be descending order. Oh, sorry, ascending order. This is descending. Descending order, and this one is ascending. So that's why ascending equals to true. So hence your basic overview of like what are the things we require is over. Now we will take some more example. This is about data analysis using pandas. Data analysis and manipulation. Okay. Now in this part, before we close off the things, we should know about one more part, and that is about how to represent the data set into a graphical manner. Like the graphical representation is one of the things that you can do. So graphical representation using pandas. Graphical representation using pandas is important. Graphical representation using pandas. So I'll take here insurance underscore DF. Let's choose age and just plot your graph. This is used for representing your data into a graphical, into a line plot. Okay. With dot plot, say I have taken the age and I have taken the dot plot, or if you can have like charges as well, and you can convert them into graphs form. With dot plot, if you will observe, your data is in a zigzag format, in a line format, but it is moving up and down. You can enlarge the size by using fixed size equals to 25, 10. So fixed size 25 is your height and 10 is your height and width. All right. This is also one of the nice thing or the nice utility here. Okay. One thing that we want to again is suppose I want to like find out the age value and I want to find out the unique age values. Like we are having insurance underscore DF, but I want to have a unique value of the age. So this is your age, but I want them to be arranged in an ascending order. For that, what we do? Sort underscore values, arrange them into an ascending order. Default is ascending only. And dot unique. Dot unique will basically convert them into a unique representation of the data. Now, this part which is here available to us can be used to create our data set. So we can use this entire thing and we can write dot plot, which will give us the error that numpy nd array, which is data type of this, has no attribute plot. Actually, this dot plot only works with when your data frame is when your data is data frame. So how to convert any form of the data into a data frame? Use cd.data frame. Convert your any form of the data into a data frame format. In spite of age, let's keep charges. That will be at least going ahead and down. So This is all okay. Uh, to represent them, to enlarge the size, we'll be using the fixed size again with 15 comma 10 say. Fixed size is to enlarge the size of the figure. Here I have used 25 comma 12. Here I have used 15 comma 10. And we require the color as well. Orange, red. This is my color. And this is how your values will be increasing. All right, over. Now, if anything was not clear to you, you can ask me on the chat window. This part is over now. This is about, you can say, one of the basic root of, or you can say the most important part when it comes to reading the data set. These are very, very important things. How exactly you read and understand the data is very, very essential. Now, after this, if everything is clear, you can just kindly write yes on the chat window. If everything was clear to you all, you can write yes on the chat window if you have understood them. If any part was not clear, kindly write on the kindly ask your questions by using mic or the chat window. Anything, whatever you would like to, um, like if you are comfortable in any part.
Participants, if you have any query, you can ask.
Participants, do you have any query?
I guess no query from the participants. So
Okay,
just
so
wait for a few minutes. We'll share the feedback link.
okay. Feedback link will be shared. Okay, so we will be proceeding ahead now with the next part. I guess the session is up to 12:30, right?
Yes, sir.
Okay. So let's do one more part, which will be about, which will give you a detail about the visualization topic. And these are, you can say, these are base part that we are understanding that helps us in uh, making our work much better when it comes to writing a program in machine learning. All right. So we'll write here the next part, the next section, that will be data visualization and we need to handle, we will be also understanding about how to handle the missing values and all. So data visualization and pre-processing. Very essential here to understand the data pre-processing strategy. How does we can handle, okay, all just let's talk about the data pre-processing and analysis. Visualization we will be we can take afterwards, okay, or as I know that you already have like you all have a discussion on the data visualization, so there is no need of repeating the same thing. So let us import our main four packages that are key pillars of any machine learning program. Import pandas as PD, import numpy as NP, import matplotlib dot pyplot as PLT, and import cbond as SNS. Matplotlib is for basic graphs. What are the basic graphs we are having? Line plot, scatter plot, histogram, bar plot, pie chart. These are your basic graphs. Next is cbond. In the cbond, we are having a descriptive type of graph. Descriptive graphs are important in this. These are C class. Did you discuss about cbond and all? Like, do you have an idea about cbond? Can you just write yes on the chat window? Participants not discussed. Okay. So one is one of the important packages when it comes to understanding the visualization part. Let's do one thing. Let's first do the visualization only, which is very essential. Data visualization using cbond and matplotlib. Matplotlib, I guess, basic of them you might be aware about it. So data visualization using cbond and matplotlib. These are the two important packages. There are many other packages as well, like for example, plotly is there, which can be also used for you can say graphs. Okay, enterprises level graph. So, but as far as the basic understanding is concerned, these two are more than enough. So I believe that we need to first take up the data visualization. Okay, in this one we will be not just taking the basic graph. Okay, anyone can tell me what type of graph you have, you know already how to create. Like just now I taught you about how you can directly take the data frame and you can plot the graph using dot plot, which will basically help us in plotting the line graph. plotting line graph using dot plot function. Okay, and this dot plot is only for data frame. It is not for without the data frame presence. Okay, so can you tell me what type of graph? I have named it here. You can see what type of graph you have discussed already: line, scatter, histogram, bar graph, and pie chart. Which out of these has been not discussed? You can tell me which part is not been discussed. First I will discuss those things and then I will proceed with the Seaborn. Mosaic plot directly, balloon plot, line plot is done. Line.
Already line, histogram, bar and pie has done, sir.
Okay, okay, that's okay. And how they are plotted, like balloon plot and mosaic plot, using matplotlib only?
Yes, sir. Matplotlib, using matplotlib.
Okay, 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 okay. Okay. Okay, fine. So I guess like you have an idea about how to plot the graph using matplotlib. So I'll just talk about the advanced graphs using your matplot using Seaborn. Okay. So in the Seaborn part, we have one of the very important graph uh, which we will be discussing, and that is called as descriptive plot. We need a data set for this. To plot anything, we need a data set. So descriptive plot is very, very essential. I will talk about that in a minute. So either you can use that insurance data set or you can choose any other data set as well. So I'm gonna take one more data set apart from this insurance. Let's read our data sets with box plot is discussed. Box plot graph. Box plot is discussed. Can you just write on the chat window box plot? No. Okay, thank you. Box plot is very important, so we need to understand that graph as well. So one graph is distributional plot. Okay, so we will be reading up first data set. So let's read our data set first. The data sets that I'll be using here first will be your insurance underscore DF, pd.read underscore CSV. This is my first data set. The second data set which I'll be using will be Boston. Boston underscore DF, pd.read underscore CSV. Let me go. I'll share the link of the data set to all of you from the GitHub. Provide the details on the single inverted commas. Got our data sets ready. Data visualization. Class link will remain as it is. You need to just refresh the link. Link will remain as it is. You need to just refresh the link. So the first 4 packages and the 2 different data sets which are available to us. Let's write here distributional plot. Distributional plots. For the distributional plots, we will be using sns.distplot use Boston underscore df medv. Okay, we need to show our data set first. See, so Boston underscore df will basically display your data, or you can use display function, and within that you can pass Boston underscore df. So crim is there, zn is there, index is there, nox is there, rm is there, age, dis, tax, pt ratio, and medv. These are all my data sets which are available to us. So when you look here, look around in this data set, you are having crim, this crime rate is zn, index is there, nox is there, rm is there, age is there, dis is there, tax is there, pt ratio is there, and medv is there. All these values are there available to us. With distributional plots, you are looking here about display Boston underscore df. All right. So crim, zn, index, nox, rm, age, dis, tax, pt ratio, and medv. These are all my details. So let's talk about like what exactly this data represents. So this data represents your uh, house prices in $1,000. This medv represent your cost of the house in $1,000. Depending upon these factors, which are denoted by crime, crime rate, zn, index, nox, rm, age, average age of the house, then distance, average tax collection, then population ratio, and depending upon them, your cost of the house has been predicted. This data set is available to us, and on the basis of this data set, we can even form our model which can make prediction about predicting the cost of the house. So display Boston underscore df, which will display us the data set. Now I'll be using here a very important thing, and that is how this distribution is normally distributed or is skewed. For that, we'll be using distributional plot. ELT.figure. size equals to 15 comma 8 SNS dot dist plot Boston underscore DF medv color equals to dark violet and plt dot show. All right, Seaborn is something which is used for complex graphs, or you can say the those type of graph that gives us the not just visualization but also some of the insights of the data. Okay, like for example, I want to see if my medv is normally distributed or not. If it is normally distributed, then the output will be much better, you can say, or you can say the prediction will be much better than your without the presence of the normally distributed data. So I believe that you might be not like, are you all aware about what is normally distributed data? Like when I say normal distribution, when I say your data must be normally distributed, do you have like understanding about this part? What is the meaning of normally distributed data? Participants, kindly respond on the chat window if your data is normally distributed or not. Do you know about it? I believe no answer is there, so I will proceed. Okay, I'm normally distributed. Yes, yes. Normal distribution. If your data is normally distributed, what is the meaning of it? See, first you should know about where this part will be utilized. Normally distributed this normally distributed data. So this part is utilized in linear regression, used in normally distributed data set uh, to like especially in the linear regression. In linear regression, this is one of the algorithm name. Or any algorithm in regression algorithm, if target data is normally distributed, model will be best fitted, or algorithm or model will be best fitted. So this normally distributed data set will be used, and by the regression algorithms especially. And here your target data is target data is normally distributed algorithm, and the model will be your best fitted model. So that's the point. A best fitted means better trained. So how exactly your normal distribution or normally distributed data looks like? So the shape will be a bell shaped. It represents the data distribution in a bell shaped manner. This is your perfect normally distributed data set. Normally distributed data set, your data distribution will be normally distributed. The shape will be your bell shaped. Bell shaped distribution. This line which you are seeing here will be a symmetrical line, and the properties of this line will be about that your mean, median, and mode, they all will fall on the same line. So one of the important properties of normally distributed data set representation is that its mean will be equal to median, which will be equal to mode. This is one of the property. So mean will be equal to median and it will be equal to mode. This is one of the important point. Okay. The other important point is standard deviation, which is called as deviation of the data from mean. Somebody's mic is again on by mistake. Participant, please take care of it. Deviation of samples from mean. This is called as a standard deviation. So standard deviation for the will be equal to 1. Standard deviation will be equal to 1. Okay. Can you tell me the I hope these basic statistical parameters are clear to all of you. When it comes to a standard deviation formula, it is given by, it is represented in sigma, which is equal to sample minus average of x divided by number of samples. Sigma is your standard deviation, n is your number of samples, x bar is equals to mean of samples, and xi is denoting individual value starting from I to n. Okay, so that's why I said that your deviation of the sample from the mean is and its summation is called as your standard deviation. All right. If your data is balanced, bell shaped, then your output of prediction will be quite better as like with respect to if your data is not normally distributed. If your data is not normally distributed, it is called as skewed. Skewness. Skewness in the data set. There are two types of skewness found. One is positive skewness. The other one is negative skewness. This is called as positive skewness. Sorry. This is your positive skewness of the data set. Positive skewness. This is your, in this case, your representation will be, first part will be your mode, of course, maximum frequency. What is mode? Maximum frequency. What is mean? Average. So this is your median. First will be mode, then will be median, and then after that, in the end, it will be mean. In the last, it will be about mean. The other will be symmetrical. Here you can see like your data distribution is like is inclined towards one of the side. In the negative skewness, this is how your data distribution will look like. This is mode. Median. Mean. This is my data distribution of, let's say, age is there, and that's how your data will be distributed. This represent your frequency. Frequency means number of samples in that particular range. Just like histogram. Histogram also does the same similar sort of a thing. All right, so that's how your data set will look like. If you have to understand this one in other terms, like suppose what does actually this graph is representing, that in your data set most of your people, the data which you have collected are younger, because the age is towards the zero. The maximum frequency, like mode is maximum frequency, so it is towards the zero. All right, so that means your maximum data is available is for younger people, and here your data is on the on towards the maximum size, say it is towards 100. So that means your most of the data which is collected is for old people. Okay, similarly you can write here in place of age, you can write marks. You can clearly say that here the class performance is very weak, as most of the students they have got very less number of marks. Similarly, if I'll write here the marks, then in this case you will say like most of the students have got a very like huge marks. That's how you can read this three type of distribution of the data set. As far as programming is concerned, that is very easy. You need to just write one line of the program, and this will be more than enough. So we are into the end of it, and that's how you can see. So can you tell me if it is this data set is normally distributed or not? Coding we have already did. So can you tell me if your data set is normally distributed or not? By looking into this example, can you tell me if your data is normally distributed or not? Yes, it is normally distributed. So we'll continue with this part. See, it is normally distributed class. Just ignore the last part. There is nothing like perfect normally distributed. These are outliers. This 50 data set is outlier, of which we will talk about in the next like phase, which will be, I guess, at 2 o'clock or something.
Sir, next session at 2 p.m., sir.
Okay. So next session, see you at 2 p.m. We'll continue with this part.
Okay, thank you, sir.
Okay. Welcome, ma'am.
So all the participants are requested to fill the feedback form. The link is available in the chat window. Thank you. We will meet you at 2 p.m.
Bye bye, everyone. See you all at 2 p.m. Thanks for attending the training program.